AI happens pretty fast. If you don't stop and look around once in a while, it might just pass you by.
Hello and welcome to The Reasoning Show. I'm your host, Brian Gracely, and today I have reason to think that if you are going to be building out AI systems, if you're going to be building AI applications and trying to bring that into your business, trying to customize that with your own company's data, your context, kind of the things that are the special sauce to your business, you're going to need RAG systems and RAG patterns. And I think it'll be interesting and important to dive into what we can learn about that from people that have been doing it for quite a while. How do you get started? How do you succeed at scale? And what are some of the things to watch out for, both in terms of green flags and red flags? So we're going to dive into that with the good folks from Pinecone right after the break. Today's show is sponsored by Nasuni. There's a growing gap in AI right now between what's possible in theory and what successfully works at scale inside an enterprise. The difference comes down to unstructured file data. Many AI initiatives struggle because the file data they depend on is scattered, unstructured, and disconnected from where and how work actually happens. Nasuni changes that. It brings your unstructured file data into a single, secure foundation so AI, both generative and agentic, can access it with the context, governance, and performance it needs in production. Bring AI to where your unstructured data lives. See what it takes to activate your data for AI and request a demo at nasuni.com/AI. Today's show is sponsored by ShareGate. You're out of time. Copilot needs to be deployed ASAP, but your tenant really isn't ready for it. Years of data, permissions, and users lurk in its shadows, ready to be exposed by AI. ShareGate Protect sees it all, so you can find the exposure risks, fix them fast, and deploy AI with confidence. Microsoft 365 Governance, they've got this. Learn more at sharegate.com/protect. And we're back and excited today to dig into a number of topics around RAG, and a topic that I know a lot of you are very, very interested because it's kind of core to so many, applications that people are using every day and they're going to use a lot in their business. So very excited today to be joined by Rowie Schwarber-Cohen, who is Head of Developer Relations at Pinecone. Rowie, welcome to the show. Great to have you on today.
Thanks for having me on. I'm really glad to be here.
You have got a lot of deep expertise around this space, but before we kind of dive into that, give me a little bit about your background, and then what are you really focused on these days at Pinecone?
Yes, I've been a software engineer for about 20 years, and in the AI space for I would say 8, and started off like way before the ChatGPT craze and LLMs in general on more traditional AI, you would say, working on knowledge graphs and computational knowledge graphs and things like that. And then at Pinecone, my focus really is making knowledge accessible and usable by developers and customers that understand kind of the value of knowledge in the space that we're in, right? Like a lot of people think about intelligence as synonymous with reasoning, and we kind of try to bring forth the idea that knowledge and reasoning are these two complementary facets of intelligence, and both are required to really get to useful systems.
Yeah. And for folks who may not be as familiar with Pinecone, obviously you guys well known in the vector database space, but kind of give this overview of where the company focuses, or where the types of problems that you guys are typically solving.
Yeah. So Pinecone started when, like you said, there were no other vector databases around, and it kind of defined the category in a lot of ways. And from day one, I think that the founders and the engineering team understood that the challenges that are going to pop up are at scale, right? So if you have, single digit documents, even 100 documents or 200 documents, you're not going to have a hard time using things even in memory to accomplish the tasks that, vector databases. But when stuff gets really scaled up to millions and billions of documents, that's when challenges really start cropping up, and you can't just use the same mechanisms to get to, the same result. And so Pinecone is really focused on two things. One is giving developers a really smooth experience and kind of easy to use a vector database, but also maintain that same level of ease of use and performance at scale. Yeah. And that's where most of our bigger customers kind of flourish.
Sure. I want to kind of begin. We're going to talk a lot about RAG, or Retrieval Augmented Generation. Let's just start with some basics for anybody who may not be tremendously familiar with this or is learning this space. Give me some basics. Why do companies begin or need to use RAG systems or the RAG pattern? And when then what benefits does that ultimately provide, as they're building applications that are leveraging LLMs and AI?
Yeah, so I think that there are, basically three facets that go into RAG and why it's useful. So the obvious thing is, and this is how RAG started basically, is that we know that LLM models are trained on a closed data set and sort of have a certain cutoff, and they're unaware of anything that comes after that cutoff, but also things that are specifically proprietary and closed off to its training set, right? So when companies want to use their own data and kind of reason about that data, they have to introduce a mechanism that will allow them to ground the reasoning that the LLM is doing with the data that they have. And so like the pattern is you first retrieve some information based on a user's query that exists within your data set. You do that semantically, usually leveraging a vector database. You inject that data that's retrieved and relevant to the user's query back into the LLM's context, and then you let the LLM generate a response that's appropriate and grounded in that information that you retrieved. So that's grounding, and it kind of covers, in the same motion, right, two other kind of facets that are really important for customers. So again, one is freshness, and like I said, right, like all LLMs are trained to a point, and then not beyond that. The fact that you're doing retrieval allows you to keep that data up to date as much as possible, and there's no limitation on what you can stuff into that context. And the second is scoping, right? Again, when the things that are not accessible to the LLM by design are now accessible to your system because you can retrieve them and stuff into the context. So that's what we usually see, like in terms of why people start using RAG as a pattern.
Yeah. Well, and it makes a ton of sense. I mean, I think you nailed it. Kind of the core case is always, you think about an organization, a business, there's a certain amount of data that, while the internet has lots of information, doesn't necessarily have your company's specific information. So the ability to introduce that becomes pretty critical, and it becomes both an important piece of the puzzle, but also in many cases, it's going to be a differentiator, just like, having that data was a differentiator for the business before. On one hand, it seems like a pretty straightforward process. Obviously, getting the data into the right format so that it can be in a vector database and cleaned and all those normal things. Where does it tend to break? You talked about the things that you guys typically solve for are things at scale. Where do the RAG models, the RAG patterns tend to break, even when people have sort of done the right things to get the data cleaned properly or into the database or into the vector database properly?
Yeah. So like you said, right, like it's the usual data problems that we all know from data science, right? So, usually engineering teams look at the RAG problem as like this engineering problem, right? Like I need to take my data and chunk it and then embed it and then upsert it and then serve it and have my LLM generate a response. But in fact, it's a data problem, right? Like the quality of your RAG pipeline depends almost completely, right, on the quality of your data and the way that you model it and the way that you construct your RAG pipeline around it. So one of the things that we see a lot is, engineering teams would start on a small corpus, right, that is largely homogeneous, right? So like it would be a set of information, concerning a particular domain, right, or from one particular department, and they would go and build their pipeline and everything will work really nicely. But then what happens over time is that these data sources become non-homogeneous, meaning you'd see multiple domains, right, that feed into that same pipeline. You would see multiple knowledge authorities, right, as we can call them, right? So you can imagine, right, that you have, just as an example, documents coming from a particular department and then multiple documents that come from, say, the CEO of that company, right? And the authority of these two things are not necessarily the same, although the pipeline will just consider them to all be equivalent, right, to one another. Right. And so the problem starts becoming complicated when these data corpuses diverge, right, in terms of like their topics. And I'll talk a little bit about, this idea of applicability maybe later, but like the core tension here is, that RAG is not just a pipeline, right? It requires thought in terms of how you organize knowledge in the scenario that you're building for, and you're solving for, And it goes well beyond just like the technical, steps for constructing the pipeline itself.
Yeah, no, that makes sense. And it does, if you think about the lessons that have been learned from people building data lakes and, all sorts of big data things in the past, it becomes very easy to sort of lose track of what was the context of that information. What's the timing and the sort of staleness of the information. It can get sort of out of hand pretty quickly. And, you just think about your day-to-day work. You start working with groups and you're like, oh, this is great, but it's 2 years old and is it still valid? Is it still relevant and so forth?
Exactly.
In talking to different companies over the last couple of years, you've done it for quite a while. I've been doing this for a couple of years. So talking to them about their RAG implementations, you oftentimes hear feedback that we got back a technically correct answer, but sort of fundamentally wrong answer. And not necessarily, that could be a hallucination, but it could also just be, it looks right, but it's not. And if you know your business or your domain, it's not. Like, how do those types of things happen? Is it strictly hallucinations from the LLM, or are there aspects of sort of not having your data right, introduce that from a RAG perspective as well?
Yeah, so this is like the topic that I'm really most excited talking about. I've been writing about this like quite a lot recently, and it's a very fascinating problem, right? Because like you said, right, like it really has more to do with the way that a RAG pipeline is set up, but not just that, right? Because there's this like there has been this like conversation on the internet, about like, is RAG dead? Is RAG not dead? Like, is it evolving?
Right.
Is it not evolving?
Right.
Like, what exactly is happening here? And obviously, right, like RAG is like a pattern. It's just saying, right, that you don't rely on the LLM to be your only source of truth, but you're trying to compose it with some other sources of truth, or you even say that the truth doesn't come from the LLM at all, but rather it lives somewhere else. So the knowledge authority lives outside of the LLM. That's all that RAG really is, right?
Gotcha.
And so the question then becomes like, okay, so if the source of truth is not the LLM, then what is the LLM's job? And what are we feeding it, right? Like, and what now causes like these failure modes, right? When we see things that seem to be like, they sound great, right? Like, and you read that, an answer and it kind of sort of ish makes sense. But when you squint at it really hard, right? Like you see that like there's something fundamentally wrong there. So a really good example that I give is, just try to simplify, right? Like this problem, right? Like you can imagine, right? Like let's say we have a utility company that, sells all sorts of products like, I don't know, toasters and refrigerators and things like that, right? And a customer comes in and says to their, RAG-enabled chatbot, hey, my toaster is broken. Can I get a replacement? Right. Mm-hmm. So you can imagine in the back of your head, right? Like, okay, so like if I'm an engineer, right, building this RAG pipeline, well, what do I do? I'm going to take all of the warranty information that we have, and I'm going to take all the toaster FAQs that we have. I'm going to stuff them into my vector database, and let my RAG pipeline do its magic, and voila, I'll get like a magical correct answer. But the problem is that you have to think about like exactly what you're going to get from a vector database in terms of retrieval, right? Because when I say toaster, right, the response that you'll get is anything that has that semantic similarity to toaster, right? And so that's going to, by definition, right, like lead to what I call a Franken answer, right? You're going to retrieve chunks that are sort of applicable to the semantic space of toaster, right? But are not applicable to the specific user's actual problem. And so the process that has to take place here is sort of twofold. One is you have to disambiguate, right? Like your system needs to have the ability to sort of pry the details that are missing from the user's question, right? In order to really give them the correct answer. And then once you do have that information, you need to be able to sort of hone in on the correct portions of your knowledge base to then produce a correct answer, right? And so the systems that we're seeing emerge right now, and the ones that we're trying to facilitate with our customers, are ones that would do that exact process, right? So instead of just giving you the answer to my toaster is broken, can I have a replacement? First, I'll ask you, well, what is the model of your toaster, right? And when did you purchase this toaster, right? So now I have like more information to go on when I do retrieve my information. So I know which essentially domains to look in my vector database and sort of pare the answer down to only those relevant portions. To do that, like, it requires a little bit of pre-work, which is essentially generating or creating in some way, and there are many ways to do this, sort of a meta knowledge layer, right, around your knowledge, right, which describes essentially what it is that you know, right? And then once you do know what you know, how do you leverage that knowledge in different situations? And that we find is like the real missing piece, right? In making this experience of like, yeah, you answered sort of correctly, but fundamentally I got a wrong answer. It makes that problem a lot less pronounced because, again, you're clearing away a lot of the ambiguity that leads to those kind of mistakes.
Yeah, no, it's an interesting problem. One of my colleagues always uses the example where he says, imagine you asked a chatbot, hey, I'm a parent and I'm planning a weekend for my kids, and my other spouse told me to make sure I get the worms. And if you were talking about taking the kid fishing and getting the worms, it would be one thing. If it was, hey, your daughter's favorite candy is Swedish, Swedish fish worms,
Exactly.
Now you've got a totally different experience for the weekend.
Exactly.
Yeah.
And it's a Achilles heel for vector databases, right? Because they're very powerful in finding semantic similarity, but they are only as good as the quality of your query, right?
Right.
And you can't kind of force that. So again, it's more of a process thinking that's required here to understand, like, first of all, identify ambiguity, which is a complicated task in and of itself, but then also disambiguating. Identifying ambiguity only comes in relation to a well-established and well-known knowledge base, meaning you know what you know, right? And you know what would be considered ambiguous against that knowledge. If that makes sense. Right.
How often do you find, as you talk to customers and prospects and different teams, that they feel like today their knowledge base is it's good enough? We feel like we've done proper hygiene on it, even pre-thinking about RAG or pre-thinking about AI. Like, how often do people feel like they should just be able to get started? And then what's the typical sort of reality of my knowledge base isn't as well prepared to sort of move into a RAG environment, or at least start that process?
Yeah, it really depends on the situation and kind of like how outward facing and risk averse the team is, right? So when you build the pattern in general, like it's like a very obvious and sensical pattern, right? Is as long as you're building internal systems with very low risk, right? You have like a lot more durability and kind of like acceptance of small little bugs here and there, right?
Mm-hmm.
And so whenever we talk to customers that are only building internal systems, they do go a long way to produce useful answers in a lot of situations, and they kind of don't care about those edge cases that might slip through. But when we start talking to customers that have actual risk assessments, right, that preclude them from releasing anything that is not like 100% correct, right? Because like there's either money on the line or some other forms of risk, right? That they might be sued, et cetera, right? Like then you see that like the teams take a long time to really perfect these systems, and usually the path to perfection goes in some way through validation and evals, right? Like building these very comprehensive test suits to kind of like cover every conceivable use case that they foresee for their chatbot. Or their system, and whatever falls outside of that is usually guardrailed, right? So like you take that approach of how to answer these, X number of questions really well, type of question really well, and if anything falls outside of that, we just guardrail against it. We don't let the system respond to these kind of queries at all.
Yeah, no, it makes sense. We've talked a little bit about the complexities of context and getting the knowledge and understanding of sort of complexities right. Like, is at this point, it's been a couple of years, like, are there fairly good patterns for trying to teach the systems or trying to organize the data so that it turns out better, or is it still kind of company by company, depends on the situation?
Yeah, I mean, largely it is dependent on the company and the situations. Like it's really like almost an organizational question than a technical question, right? So like again, in companies that, have like a single RAG pipeline or a single RAG system, it's very straightforward, right? But like we have customers that literally have thousands of these systems, right? Like, and then the question becomes, right, like it's much more about data governance, right? And just generally, like, how do you, again, eliminate risk or at least manage that risk in a way that is feasible, right, for like organizations at that scale. And I can't say that there's like one silver bullet, right, or a pattern that kind of works everywhere. Every situation really is kind of unique, and that's to be expected, again, because it goes back to what we discussed in the beginning, right? Again, RAG is not a particular pipeline, right? It's just this notion of using knowledge with this ability to reason over it with LLMs. And that is a process that has existed even before LLMs, came into the picture at all, right? Like we had all sorts of ways to reason about knowledge with heuristics, with other modalities, right? Like they kind of helped us funnel that knowledge and understanding into a product. And there, you couldn't just say, yeah, like there's only one way to take that information that you have, take all the documents or data that you have and funnel it out into a product that will work for everybody, right? And for that same reason, right, like there's not really a dominant pattern that we can see.
Yeah. You hinted around, well, I don't want to say you hinted around, you sort of mentioned that, the internet loves to say things like, hey, is technology X dead? Is RAG dead because models have gotten better?
Yeah.
Have you seen anything, obviously we're seeing more intelligent or more powerful models emerge. We're starting to see reasoning models emerge, but those are also, we're seeing them consume tons and tons of tokens. And as we get into the economics of things like, that's driving some costs up. Are you seeing people sort of, a lot of times technologies will have sort of a second, sort of a second coming, if you will, when either the economics change or some other dependency changes. Like, have you seen, being good, having good hygiene around RAG starting to sort of come back around if people are seeing their costs go up because of reasoning models? Or is there any sort of relationship between the models doing more things on their own and then people being like, oh, wait a second, I ran out of tokens or something? Does that come into play at all yet? Have you seen that at all?
Yeah, to some degree, I have to say, like, I personally think about this in the opposite way. Right? It's like, I think that, like, if you look at the reasoning capability compared with the cost per token, reasoning is actually getting cheaper over time, right? Mm-hmm. And not more expensive. Like, it's getting more powerful, and the things that you could do with it are just increasing. And so, like, the frontier models are obviously more expensive. But if you look at, your smaller models, like your minis or your nanos, right, and all of the flavors that come right with each model, those are incredibly powerful models, and they are capable of doing really extraordinary things that, we would have considered state of the art just a year ago, right? The question that I think people are kind of realizing is like, what happens so reasoning is not the moat anymore, right? Like your ability to reason about things is not a moat anymore. What is the moat? And I think that one of the reasons that people are sort of going back into knowledge is because knowledge has this unique quality of being composed and decided on by humans, right? Like by experts. And the uniqueness of each composition is the moat, right? It's in fact like your ability to say, like, our understanding of some domain, particularly in the world, right, like is very, efficient or, has some edge, right, compared to our competitors, right? That is the thing that actually allows companies to really maintain their advantage when everybody else, right, has the same reasoning capabilities, right? And so I think the pattern that we're going to see moving forward is that, in fact, like, again, in the past, you would have companies working really hard on building ontologies and building knowledge graphs to sort of make the knowledge that is hidden in the expert's brain, right, sort of accessible and usable by systems downstream. Now we have just a different layer that wraps around that knowledge, which is, LLMs and natural language. So we have this natural language interface into that knowledge. But the thing that, and again, that kind of has become commoditized to some degree, right? Like the ability to reason about things, the ability to access them with natural language is becoming commoditized. What's not becoming commoditized is the actual knowledge itself. And so if you can, as a company, build and improve upon your expertise and the expert knowledge that you compose, that to me, right, represents a far better moat to, invest your energy on than anything else, really. I hope that made sense.
No, it does make sense. And no, it's interesting, like you said, to think about it in terms of moats and where you put your where you put your focus to try and, leverage information to not only, get correct answers and to provide, sort of a quality of service, but then also to think about it in terms of being able to provide a differentiation, either based on, previous data you've captured or anything else. I'm curious, and I'll sort of wrap up with this last question. So you've been obviously around this space, like you mentioned, for quite a while. What are some of the things that you've got kind of on your radar as next things that are going to enhance this space or make it easier to use or just overall provide better quality of experience?
I think that like the movement towards agent full autonomy is really like very interesting to me. And I think there's like some key components that we need to still figure out, specifically around, goal setting and memory, which I think are interconnected. So I think if you think about like, agents doing different things and on our behalf, right, and interacting with either knowledge or other systems, et cetera, right? Like you constantly have like this experience currently, right? Like of sort of having to babysit the agent, right?
Yeah.
It's sort of like, I shoot off my thing and then it goes and it does like something for me. And, as time moves on, right? Like it's very interesting to see, right? Like the length of time that an agent can operate kind of autonomously until it needs to come back, to ask for your advice or approval or, something of that sort. What I think is going to be very interesting is, how these agents sort of understand their context better, how they can reach into tools autonomously better and leverage those systems that they have access to without coming back to ask for more guidance or approval and, sort of accomplish more of the goals that are set for them on their own. I think that like that really does require us to think very deeply about like how agents form goals in the first place, right? So like how do you set, when you set an agent to do a thing, it starts with like the particulars of what you told it to do, but obviously like it needs to understand how to like break apart that goal. If it runs into a problem, it needs how to solve that problem, and there you get a new goal. And then you need to understand, like the agent needs to understand how to learn from its past experiences. And that requires memory and the ability to retrieve that memory and understand how it applies to any particular goal that it's currently looking at. So that's like an area that I think is still ripe for innovation. And we're definitely very interested in participating in that. And I think that like we're going to see a lot of work coming out in this area in the coming months and years.
Yeah, no, good stuff. Rowie, I'm gonna cut us off there just because we've dove into a number of things. We're probably gonna, if people are very interested in this, I recommend they follow up with you guys, follow up with Pinecone. You guys have been doing this for quite a while. It's a space that is very, very valuable to sort of every organization that's beginning to do AI, because your business knows your data more than anybody else. You know your space better than anybody else, and the ability to introduce your information into AI experiences is very, very important. So thank you so much for helping us kind of walk through both the basics as well as some of the challenges people have, how they're solving them. Folks, with that, I want to thank Rowie for time today. Thank you for his insights, and hopefully it was useful to all of you. So with that, folks, we're going to wrap it up. Thank you all for listening to the show. Thank you all for telling a friend as we're trying to grow the audience. And with that, we'll wrap it up, and we'll talk to you next week.
Check us out online at reasoning.show for all things reasoning. And leave a 5-star review wherever you listen to the show.